In this tutorial, I'm going to talk you through some of the skills that you need to do for Challenge 3 Stripboard. First thing, as with all the challenges, I need to make sure I open a Word document as my evidence, okay? Because all the challenges have lots of little bits, and it's easier for you and easier for the teacher if you just hand in them as one go, okay? So I'm going to start with my Word document called Challenges 3, okay? And so I've got somewhere where I'm going to put my screenshots in. Okay, so let's have a look at what is Challenge 3. Well, Challenge 3 is designing circuits for building using this material called Stripboard. Now, you may have used a breadboard before. They're quite similar. Okay, this is a little bit more less temporary than a breadboard, but it is still a kind of it involves a lot less equipment. So if I want to build a circuit at home, rather than having to have kind of an etch tank and chemicals and all these sorts of things, I can actually buy Stripboard from eBay or Amazon, and it's got all these little holes in, so I can put the components through. Okay, as you can see, look, this one here, for example, they've pushed the power through, so the power must be going along that strip, okay, and then the ground wire's coming through here. So all the circuit must be going through here, whittling its way all the way around and back to there. Okay. Now, let's have a little look. So to get the program up, it's a bit unusual. You need to actually load it from the Open Drive. Okay, so let's go to the Open Drive. So at the bottom, click on the folder. Go to the Open Drive, Design Engineering, Student Home Software, DIY LC. And it's this, the file you want is here. Okay, DIY application. So you double click on there and that will open up the program. Okay, and it should look a little bit like this. It will say DIY LC. The original use of this is to actually build guitar amps. So lots of the kind of components in there are specific to building guitars and things like that, which we don't need those specific components, but it does have all the bits and pieces that we need. Okay, on the left hand side you'll see there are all the little folders to sort of store in all the components, so you can kind of open them and close them. Okay, so we can have a quick look. So the first thing I'm after is what we call the board. Okay, so click on boards, and the one we use is called the Vero board. So I'm just going to drag that in. Okay, I'm just going to zoom in a little bit so you can see a bit clearer what we're looking at. Okay, and you'll see that it's numbered and lettered. Okay, so you can actually see that all the little holes. So this is a little bit confusing, is that you're actually looking at the back of the board, and we're going to put the components here. In real life, the components would go on the other side, on the kind of cardboard side, and then you'd solder these in. Okay, so if you ever need to use this, just be aware that it's kind of almost back to front. Okay, so what does it ask us to do? Well, let's look at what is the task. What circuit have I got to build? Okay, well, the first circuit we're going to build is this, right? It's about as simple as it can be. We need power, a resistor, and an LED, and they need to all connect up. Okay, so this is for the silver challenge. So let's have a little look at the task. Sorry, I've just opened it up again for some reason. Okay, so what do I need? Well, we're going to need some wires first of all. So you don't show the battery on this, you just show wires. So if I go to connectivity, and I'm going to grab a hookup wire. Okay, so I can just click on there and drag it in, and make sure it actually goes in. So I'm putting this into A14, and I'm going to grab another one, and I'm going to click this one onto K14. Now, traditionally, the colors for positive and negative are black and red, so I'm just going to double click on this one, and I can go to color, American spelling, and I'm going to change this to red. This will be my positive wire coming in the way, and this one here, I'm going to have that as my black wire, so this is going to be the ground or negative, sometimes called a reference. Okay, so I've got my power in and power out. So okay, let's look back. So of this bit, I've built that bit. Next I need is a resistor and then an LED. So let's go and grab those. So I want to find the LEDs under, now let's see if I can remember where they are. There you go. So LEDs are under semiconductors. So I just grab that and bring it in. Now when you bring it in, you'll just get a green dot. So you need to say, right, well, I want it to go from here to here. Okay, always work, because the electrons are going that way, always work that you want to put the components going kind of up and down. You can put them diagonally, but I would, to start with, at least work on them just going up. So I'm just going to move that right across there. Okay, so I'm not wasting any copper. It's going to go into there and along onto the strip. So I need my resistor needs to connect G to K, all right, because remember, it won't actually flow. Let's go and find that. It should be under passive, and there you go, resistor. And again, just click where you want it to start, and then click where you want it to end. Okay, and you can kind of move it that way if you want to. Okay, so that's the silver badge done. All right, now always when you're doing these, just check. Okay, so think, right, I'm an electron flying along here, I'm onto this bit of metal here. At that point, I have to go through here to this strip here. That's connecting to this component. I have to go through this resistor, and I have to go through there. So as long as there is a connection, a constant line all the way through, I have to go for it. Okay, the electrons have to flow. They've got no choice. They have to go. I can even make the little board a little bit smaller if I want to. Okay, so that's my first one done. Let's have a quick look at some of the rules. Okay, so some of the rules are of using this. I can't put two things into the same hole, because remember, this is designed to actually put things through. So if I connect that to there, the computer will let me do that, but in real life I can't. These wires are 1 mil, that hole's 1 mil. Can't physically put that in there. Okay, if you make a mistake, Control and Z, I can just undo that. So that's your first one. Make sure that they are actually connected. Lots of people hand things in that kind of look like that, and you think, well, hang on, okay, I'm an electron going through here. When I get to that strip there, that's not connected to anything. It has to connect to there. Okay, when I get to this one here, where does it go from J? Well, that needs to come up one to there. So it has to actually flow all the way through. Okay, unfortunately, this doesn't have the facility to change it. So there's no button you can push that actually tests it, which is a shame, but you have to actually just sort of yourself go through. Okay, you can, if you want, to change the value of resistors. If you double click on them, you get a name. You can just change that. So this is meant to be a 330, and just say OK, and that will actually show you as a 330. All right, so that's that silver badge done. Okay, thinking, would this work as well? Yeah, hopefully you should be able to see, well, actually, yes, that would work. It can flow through there, round here, out through there. Okay, so would that work? Yes, it would. Okay, so there's all sorts of kind of combinations. You can make things a little bit smaller if you want to, as long as, okay, everything actually connects up. You can't, another rule, you can't have things overlapping. Okay, so you couldn't have that. You could have that maybe, as long as, again, I move that up to there. Okay, so I wanted to go even smaller, I can do. All right, so that's quite dinky, isn't it? That's getting quite good in terms of actual space. All right, I might even be able to go a little bit smaller, perhaps, without bumping into anything. Okay, I can maybe move that across there and that there. This, obviously, with the resistor, would be sticking up in the air. Okay, which you are allowed to do. Okay, go a little bit bigger on that so I can see what I'm doing. Okay, that's about as small as I would want to go realistically. Okay, any smaller than that is starting to get a bit daft. Okay, so that's the first one done. When I've finished, obviously I go to my Word document, Insert, Screenshot, Clipping, wait for it to go cloudy, I draw around that, and that puts that in there. Okay, so that's my first one done, and then I'm going to do the gold. Now the gold, there are two parts for it. Okay, so I'm going to go a little bit quicker for this one. Okay, but there they go. We've done the silver together. Let's have a look at what gold's asking. Well, gold is the next circuit along. Okay, so you can see now I've got 3 LEDs and 3 resistors. Same power in, power out. Okay, so I'm going to need a bigger board, so I can just grab that and make it bigger. Okay, and now the key with this, okay, let's just move that side down to there and move that down to there. Okay, there you go. So looking at the circuit, I've got 3 connected. Now they're connected in what we call parallel. So yes, they start at the same at the top. Yes, they finish at the bottom the same. but they are not connected on this bit here. So when I do this, I can't have these on the same row. So let's have a quick look at a quick example. If I just do a couple, you can see. So I can just go copy and paste. Okay, so they're finishing on the same row. That's okay. I can copy and paste that. Okay, that's starting on the same row. That's okay. But I can't have this where they're connected, because otherwise electron could flow through there, but it could also go through there as well, and then this one could go through that one as well as that one. Okay, so it'd be a bit chaotic. So what I can do is if I just make it a bit shorter, so if I just move that up one strip, okay, that is now completely separate. They both start at the same, they both end at the same to the ground, but that one's going through there, and then this one's going through there. Okay, so you just need to put another one in there, and again have it on be a different rung. That would be for the first part of gold. Okay, for the second part of gold, it asks you to build this circuit here. Okay, and now some of those components look familiar. Okay, so hopefully again I've got my power in, I've got a couple of resistors this time, and I've got an LED, but I've got excuse me, I've got these two components here. So let's show you where they are. So back to my circuit wizard. So I need resistors, I need two resistors and an LED, just one, so I'm just going to move that across. So we need that K shape. So if you go to schematic symbols, and the second one down is called a BJT, a bi-junction transistor. Okay, so I'm going to put that K shape in first. The other thing we needed, let me just check again, was this LDR. Okay, so an LDR is, now I don't think we're going to find an LDR in there, so what we'll do instead, we'll just use this electrolytic capacitor. Okay, it's the same kind of symbol, same sort of shape. Okay, and that'll work fine for it. Okay, so then I've got to rearrange these. I can change the values because obviously it asks me for a 100 and a 220K. Now the key with this is think about this component. So on that middle strip coming off the back of here, I've got to have a resistor joined to the end of it and the other component going down there to ground. Okay, so let's have a quick look. So that one there, can you see that middle one is connected there down to ground, and then I would need to have a resistor there which is connected up to positive there. Okay, so that middle pin I've got connected up and down. The LED, you need to connect it down the way, and then the other resistor connects to that top pin like that. Okay, and obviously put the labels in. Alright, so that's what that one should sort of look like. Okay, just checking that they are connected up, that's connected up to positive, that's connected around to ground. Okay, so that was the second part of gold, and let's just give you some more, a little hint on how to do platinum. Okay, now the platinum ones, alright, are obviously that bit more difficult, so you need to have a go yourself. Now to do the platinum, you're going to need, let's look at the circuit first of all. Okay, so the heart of this is what we call a 5-of-5 timer. Okay, so we're going to need to find one of these. That's a capacitor there. Okay, and then you've got 1, 2, 3 resistors and an LED. So let's have a look. So actually, that's a capacitor, so that's easy enough. You've got your LED. You need 3 of those. That's okay. So you just need to copy and paste another one. Don't need the BJT. You can get rid of that. What we do need, okay, is going to be under, let's have a little look. It's under semiconductors and it's called a DIP IC. Okay, so I can just drag that in. Now on there, if I double click, I'm going to say display pin numbers yes for DIP. Okay, so display pins DIP. Say OK. Now you'll see I've now got the numbers 1 to 4, 5 to 8. So that's going to help me figure out where does 1 go, where does 2 go. Okay, now what else do I need to do on there? Last little bit, and then I'm going to say you can get on. I need to, obviously if I put that straight on there, the nature of the metal going through there, 1 would be connected to 8, 2 to 7, 3 to 6, 4 to 5. So that's no good. So what I can use under connectivity is something called trace cut. and that will actually put a hole in there. So when we do this in real life, you actually get like a little mini drill bit, and you actually